Well, hello everybody. Good evening. Welcome to. Oh, let me share my screen. Welcome to just finishing off. What was it, like week 8 or something? Yes, week 8 of advanced programming with Java here at Portland State University. We're getting on towards the sort of the final parts of the course. Only got a few weeks left. It's great. Hey, we made it this far through the winter. It's particularly cold today. But hey, we're coming up on March, and that means the end of the term and spring break coming up. I'm sure everybody's going to like Florida or Baja, right? That's what I don't know. Spring break's probably different now. Tonight, though, we're going to focus on a couple of things. First, as always, we'll start off with Prime Minister's questions. I'm really curious to hear how the REST API project is going for folks. We'll spend most of the stuff that I'll be telling you about tonight is getting started with Android development. Android development is the thing we do here at the end of the course. It is the final project. We'll be talking about that also. And what we'll do is we'll get all set up, or I'll show you how to get your environment set up to run an Android project. And then we'll talk about Project 6. And then we will do our second mob programming kata, an RPN calculator, which should be cool. So a couple of big chunky things on the agenda tonight. I hope to give you plenty of time for the mob programming because what we heard last week is that people enjoyed it, but they wanted more. So this is your chance to get some more. But to start with, what can I tell you? So Prime Minister's questions. I hope people have had a chance to start digging in to Project 5. The REST API, the client and the server, as we've seen over a couple of weeks now, it is different from the first projects in the course. We're only dealing with one Java program. Now you have two that are talking to each other. Lots of different concepts, lots of new styles of programming and debugging. But what questions do you have right here and now, realizing that the project isn't due for another week? What can I help you out with tonight? Please feel free to come off mute if you are remote, or if you want to post a question in the chat, you can do that also.
So I have a question. I
Mina, yeah.
I noticed that there is no resource folder in the skeleton folders that was created with the script. Is there no such thing as resources when we're doing this, or should we be creating our own resource for the README file? How does that work? Or is it because we should know to create our own resource file or something?
Sure. It wasn't because I just forgot to add one. Yeah, you should know how to do that. But yeah, actually, yes. I didn't bother to create one since you all know how. But yes, please, if you're using a resource for your README, then please add one to the please add one to the project under source main resources. Yep. So just copy the whole directory hierarchy from project 1, 2, 3, 4, from the airline project into the airline web, and that should be okay.
Sorry, does that do the same for the Java doc folder as well?
Yes, although the Java doc folder isn't necessarily required.
Not required.
Yeah, no, I think you could probably get away without it. I'm just, you know what? I'm thinking about it. It's like I should just make sure that works. So let's quick do that. Let's see here. So here in airline. Oops, I still have my Android. Yeah, never mind. We'll fix that. Okay, airline, and we have source main resources, which just contains the README. So here we want the airline web.
Are you showing us something?
I am. Oh, I'm not sharing my screen the right way, aren't I? Thank you. I was just sharing one window and not the entire screen. Old habits die hard. New share entire desktop. Thank you. Let's see here. Maybe I'm not. Am I? New share entire desktop. Share. Okay. Are you able to see my IntelliJ now?
Yes.
Excellent. Okay. So I found in my airline application, or my airline Maven project, I've got source main resources, and I want to put that in source main resources down here. So I can just right click and I can say copy, and I can say in airline web source main paste. It says make a copy directory into resources to directory source main. That's good. Okay. And let's just make sure that I can load that README resource. And so what do I have for tests here? Integration test, airline server test. I will just add something really quick to my main program here. I'll just say test and void README option prints README. And so I will say main method result equals invoke main. Oops, sorry, let me add. That's why I thought I heard someone show up, but they're not showing up. Okay. Invoke main project 5.class with dash readme. And I will assert that result.get standard out contains string. What is in that readme anyway? This is a readme file. Okay then. And so if I run this, it'll fail right away, but let's just make sure. Yep, nothing was written. So now if I just go to my project project 5 over here, and args. So if arg, oops, arg equals dash readme, then print readme and exits. So then input stream readme equals this .get class .get resource stream readme.txt. Oops. Oh, it's a static method. Fine. Can't call. Yeah. Part5.class. Okay, and then I'll just say oops. Buffered reader equals new buffered reader and a new input stream reader around the README. And what does not like there? Parse no exception. Yeah. Nope. And now for string line equals reader dot read line, while line doesn't equal null. Line reader dot read line. Out dot print line of line. Okay, and now I should still have a problem here. You, of course, should handle your exceptions better than this, but I'm in a hurry. Does that read? No, it does not. No pointer exception. Aha, I could not read it. Let me,
Do you have to rebuild the project?
yeah, I think I have to like either rebuild or I need to refresh the project. EDPXCS410J Whitlock, just make sure we're in the same project. EDPXCS410J Whitlock, yep, and they're in main. So I think, let's try that again. Nope. Okay, yes, let's rebuild the project. Okay, so the project rebuilt. Yay! Thank you for that advice. That worked. So we rebuilt the project because it didn't know about the resources directory before, but now it does. And so then I put the resource in the right place, and I demonstrated that it can read it. So yes, so it looks like all you'll need to do is just copy your resources directory into the airline web source main resources directory.
Okay, thank you.
Nice. What else about Project 5? Have people had an opportunity to really break ground on it and start working with the servlet, start working with the airline REST client? I'm curious, after we walked through all this stuff last week, if anybody has any observations, any feedback, any questions about what's going on there. No? Okay. Well, that is fine. Oh, yep.
I said not yet.
Not yet. Okay. Yep. That's cool. Okay. Well, then, yep. Feel free to reach out during the week with questions. I'll try to get to them as best I can. But hopefully, after what we walked through last week, most things make sense, and we'll be able to see both last week and the week before, actually. Give you a pretty good idea of what all the pieces parts are, because there are a lot of them. Okay. Any other Prime Minister's questions for tonight? Nope. Okay. I'm going to quit my IntelliJ to save some resources on my laptop, because now we're going to do something completely different. Okay. The final part of so let's see here. Every time I've taught this course, we've culminated in writing a user interface, a graphical user interface for the project. Contemporary software has a user experience to it. Very rarely do we only write batch processing jobs or have a curses interface where you're it's interacting with the terminal. Sure, there's lots of software out there, and it's really great software. But the vast majority of what we'll do in our careers probably involves some sort of interactive user experience. So either a thick application like the web browser, or like IntelliJ or Slack, or any of those things, right? There's a rich interaction there. Also, web, a web interface. No longer do we have just plain old HTML and static structured text. Now you have as much richness in the web browser as you do in any interface. And of course, the interface isn't just on a desktop or a laptop anymore. It's on small devices, on your phone, on your tablet, on your TV, right? There are all of these devices now that are all interactions with software, right? There's no hardware there anymore. It's not like you're turning the dial on your TV. No, you're interacting with it the same way that you would your computer. So And I want you all to experience this. This is a great, I found, and certainly when I was a student, some of my favorite classes were my UI classes, where I got to not only make applications that seemed much more real, much more fun, but boy, the coding was just sort of like another step beyond. And as we start diving into Android, I hope you'll get an appreciation for how you can code these applications and how reacting to asynchronous interaction by the user is different from what you did in project 1, where you start at the beginning of your main method and you execute that straight through until you end, or even in your project 5, where you've got this web browser, you get this web servlet that reacts to only a couple of things. Well, now you'll have a rich interaction where you can have button clicks and you can have text being entered, and all sorts of, and how you and then how you code that and how you actually make that application is something that I want you all to experience. But to get started, we're going to experience that by developing an Android application. Now, Android applications can be developed in Java. That's the original language for it, and I think still probably the primary one, even though Android applications can be developed in .NET or Kotlin, and probably other languages too. I think Java is still probably the most popular, even if it's not the one that gets the most press. And so then the thing I like about Android and why I use it is because it allows you to leverage the Java language that you've learned, many of the Java APIs that you've learned, and the Java development environment that you've been working with to write Android applications, which are much more fully featured and ultimately, I think, more interesting than just the command line ones. But as you can imagine, in order to get started, you have to do some things that are different. Now, we'll come back to the Project 6 assignment later in class, but what I want to focus on now, and for the next, probably half an hour or so, is how you set up your environment. So I'm going to be walking through installing some software and getting everything all ready for that, and creating a project which will eventually evolve into your airline application. I encourage you to follow along at home. This is a lot like week 1 in that you'll need to set up your environment, install some software. And history shows that sometimes, especially if you have an older machine or maybe something a little unusual, like a flavor of Linux that isn't well supported, that you might need to take some extra steps. There's lots of help out there on the internet, but it's something that I would like you to spend some time tonight getting to work, or at least sometime tonight or the next couple of days getting to work, so that you've got a confident environment that you can then develop your project in. You don't want to be, find yourself 3 days before the project is due, only to realize that you can't run Android Studio on your machine. Okay, I probably need to fix that, but anyway. So if you scroll down to the second page here, there's this URL. Let me post it here in the chat. Oh, I'm sorry. Wait, there was a question in chat from James that I only just saw now because I was moving things around. James asks, we don't need to write any of the non-XML parse write functionality for Project 5, do we? I'm not sure exactly what you mean by that. The text parser is not part of Project 5, that's what you're asking. And it's very likely that you can just reuse your XML parse and write functionality from Project 4 for Project 5. The only caveat I'll call out is that in Project 5, you do not read and write XML files. You write XML data to like the print writer from an HTTP request, or read it from the string that's returned from the on the client side. So you might need to change some of that, but otherwise, the logic for generating and parsing the XML shouldn't change at all. Or shouldn't need to change. Okay, so start with Studio. Okay. So here, I want to open that up in a new tab. Here we go. Okay, so Android, and you can watch this in the lecture, is a platform for developing applications for small devices like phones and tablets and box top sets. All that great stuff is developed with Android. And again, as you see in the lecture, it's built on top of Linux. It's really robust and secure. I mean, it's a nice platform to develop in, and you can develop the applications in Java. Now, there's a tool, an integrated development environment called Android Studio, which is actually derived from IntelliJ, that uses all of the JetBrains libraries and stuff to develop Android applications. And so this page here walks you through all the steps for creating that. And so each one of you will have to go and do this on your own in your local development environment. Note that I do not believe there is an Android Studio environment available on PSU machines. Certainly not on the Linux machines, and I don't know if it's there on any of the Windows machines. If anybody has a challenge with that, so either the development machine, your laptop or whatever, won't run Android Studio, or maybe you don't have one and you always use the PSU machines, please reach out to me as soon as possible, so that we can try to figure out how to make you successful with this final project. So the first thing you need to do is install Android Studio. So here, and I'll post this link too. This is the link to Android Studio. I'm not going to watch you develop this. I mean, download this. It's like a gigabyte of stuff. I downloaded it the other day. I think I did anyway. So where are my downloads? Yep, there's mine. So I'll run that shortly. But anyway, this is a cool little page that shows you everything that Android Studio can do for you. So you'll be clicking this download Android Studio. But what it gives you is essentially IntelliJ. So it looks familiar to everybody. You can browse your file hierarchy and really they have different views of the files over there on the left. Because Android, the visual, Android applications are visual. One of the awesome things about Android Studio is that they give you a WYSIWYG editor where you can draw out your user interface, and then it'll automatically sync it with these resource files. We'll learn more about that stuff next week when we really start diving into the Android application. Of course, it's also there in the lectures online if you want to view those in the meantime. Android Studio is a great piece of software. They're always adding new features to it. They have a lot of stuff. We probably won't be using it too much in this course, but you can do things. What we will be using in this course is the ability to launch the Android application inside an emulator. So one of the things that Android has is an emulator for all supported devices. So this allows you to have a software version of the hardware thing. So you can do things like, hey, how does my app look on this kind of phone, on a Google Pixel, or on a device of these dimensions and stuff. So it'll simulate all of the different devices that are supported. And I'll also let you do things like profile the simulated device, and so you can sort of figure out, oh, hey, are there CPU hotspots? Are there is there bad resource utilization and stuff by my application? Probably beyond what you'll be doing in this course. The goal here is just to get it to work and look halfway decent, have it be usable. But I'm pointing this stuff out to you because, hey, I hope you'll have an opportunity either, as a student or professionally to dive more into this stuff if it's something that interests you. So again, it's got the visual layout editor for creating your applications. And other stuff as well. The APK analyzer lets you look at what's there in the actual application that's downloaded to see if there's like super big files or anything that can be shrunk down. And you've got IntelliJ, right? And so you've got all the stuff that we're used to in terms of as you're writing your code, you can have autocomplete and everything like that. Note that a lot of the examples that you'll see out there use this language called Kotlin, which looks a lot like Java, but isn't Java. It's built, but actually it does compile down to the Java virtual machine. and then you can run that on the Android device. Oh, one other important thing to point out, all along in this course, we've been using Maven to build our projects. Android applications use Gradle, which is kind of the successor to Maven, which has a bunch of different properties. And so I prefer Maven for all of the sort of like easy stuff, like building command line applications and doing web applications. But for something more complex, like Android, Gradle does a really nice job. Hopefully, just like with Maven, you won't need to modify too many things about the Gradle. You'll just know it's there. Anyway, lots of great resources. Of course, it's in Google's and really all the people that are involved with Android. It's in their best interest to make sure that Java developers like you can get started really easily, are well supported, because they want you to build. Well, they want you to build applications for their devices so that people will buy their devices to run your application. Okay. So anyway, that's an overview of Android Studio. I suppose I could have been downloading that while all of that happened, while I was talking about all of that, but instead, let's just go and run the installer. Okay, so here on the Mac, let me get rid of the downloads. Here on the Mac, I just get a simple drag and drop. So I drag Android Studio into my applications. Oops, what the heck happened there? I guess applications. There you go. Okay, and it's sitting there and installing it. Copying it there. It's doing its thing. Android Studio is not small by any means. And actually, one of the first things that we'll do as we get started with Android Studio is download a whole bunch more stuff. Because Android Studio needs all of the Android runtime, it needs various APIs, and it needs an emulator, or it needs whatever emulators you choose to install to do its thing. So here I am, I'm running Android Studio. Oh, some questions here. Eric's reports success, that he was able to download and install it. Nice, pretty easily. Oh yeah, it does give you a warning if you have an AMD processor, and there's a little script that you have to run. Good to know. Glad it worked for you. Let's see if I have same amount of success. Let's see here. Here it is, opening it for me. The Bumblebee release. Okay. Oops, that was something that was old. So here we are. You're probably seeing something like this. It's an empty, it's saying, hey, welcome to Android Studio. So even though it looks a lot like IntelliJ, it's a separately different installed application. And so what we want to do here, let's see here, plugins, there's one thing that's telling me, oh, lots of stuff that could be updated. Meh. Never mind. Let's go to projects. First thing we're going to do is create a new project. So this is just like, this is equivalent to opening up your pom.xml. So here's an important difference between the other projects and this one. So in the other projects, we have those create scripts, right? And those create scripts like sort of got everything started for you, laid out everything the way Maven likes it, made sure all the dependencies on my code were hooked up. I didn't go to that effort on the Android project. They're much more complex than the other projects, and also I can't use Maven archetypes to create things so easily. And so then here, what we're going to do instead is we are going to just create a new project from Android Studio. So click on New Project. Now it has a whole bunch of different project types. There, everything from like, oh, I want to create, and actually the projects all start with something called an activity, and you'll learn what an activity is in the Android lecture. And it lets you get started with all sorts of different kinds of things, whether it's like Google Maps activity, or using the fragment and model view API. We just want an empty activity, something super easy. So choose empty activity and click next. Now you have to name this. I am going to call this airline-android. Oh, yep. Package name, I'm just going to change mine. Actually, I'm going to change mine to Whitlock Do I want Android? I don't have to. Just use mine. Okay, and I'm going to change my. I want to put mine into GitHub, right? This is going to create a bunch of Java code, a bunch of XML files, some other stuff, and all should be put into GitHub so that I've got the repository and everything, or I can I can check in my code and roll back and all that good stuff. And I'm going to put it here in a directory in my Portland State Java Winter 2022. So this is exactly where I have all my other code for the course. And I'm going to put it in a directory called Airline Android. I'm going to use the Java language. You can also choose Kotlin, but use Java, please. And the minimum SDK. So this is the Android software development kit. So yes, there's Java involved with this, but there's also a whole bunch of Android APIs. It's really cool. You can choose those sort of different ones, and it can tell you like how many devices out there in the world run will support that version. So of course, the older you get, the more devices you'll get. But I recommend that we just go with 29. That'll give you sort of some nice new APIs. It'll run well on the emulators, all that kind of stuff. So API 29, which is the default. This is Q. They used to be named after desserts, right? So it went from like, okay, well, this one here is jelly bean, but it started with A and stuff. Now we're at, and after pie, they decided to give up. Apparently, there's no good desserts that begin with the letter Q. And so here again, the name Airline Android well, actually, the activity, we probably want this to be airline activity, because I want the name of the activity. Package name, just use your package. Put it in the airline Android project. It would be Java and API 29. Okay, and now it's opening something that looks a lot like IntelliJ. But because underneath the covers, it really is. They just took IntelliJ and added a bunch more stuff to it, which is super cool. Now, you'll note that it's doing all sorts of things down here. It's building Gradle. I'm going to open the build tab here so we can watch what's going on here. It gives you that nice tip of the day. That's great. So what it did was it created some source code out of the box, and now it is building that source code for the first time, initializing a bunch of stuff in the project. I'm going to open up the build tab so we can sort of see what's going on. It's using this Gradle tool, which again is like Maven but different. It does the same thing as Maven. Question came in from Mina. Did you not have to download components? I'm on the setup wizard that is downloading a bunch of stuff. Oh, you very well may. Darn, I thought I had blown away all of the Android stuff from that. Yeah, you might be having a very different experience then if it's asking you to download things. Mina, would you mind sharing your screen so we can see what you're seeing?
Yeah, I can. I can't share because we're sharing.
Yep, I think I've given everybody permissions. That'd be very helpful. Yeah, sorry about that. I guess I thought I had cleared away all my old installed stuff, and maybe I haven't.
This right here, it like went to, I guess it just finished downloading, but it was asking me some questions, like agree, and I have to agree, and then it went to like a bunch of downloads. Did I do something wrong?
Nope, that's probably the right thing. I'm guessing that because I already had API 29 installed from like last time I taught or whatever, it didn't need to download it again. I thought I had deleted all that stuff, and maybe I hadn't. Okay. So yes, one of the things that you might find is that there are some additional steps for you to get this working in your environment. This is good. Okay, so yeah, so it's like all the build tools and everything like that. Oh, it's that library Android SDK. Okay. If anybody's having problems with, let me know. I can always do another screencast where I delete more stuff and you can watch me download all sorts of stuff. It's not working.
Okay, as long as I'm not doing something wrong. I think Eric had the same downloads. So okay, thank you.
Yep, no problem. Thank you.
Yeah, I had the same experience. It took like a solid couple minutes to download the rest of that after the main file, but then it pretty much walks you right through it, and then it worked okay.
Awesome. Okay. So then, yeah, after you download all of that stuff, you'll be Android Studio will open up, and then it will do all this building of the thing. If you open up the build tab, you'll see that it's doing its Gradle thing. Looks like it was successful. This is good. So let's see what we got here. We have over here on the left, you can browse through the files that are created. Oops. Browse through the files created just like you would anything else. We've got all sorts of things here. And I'll go into more detail next week when we really dive into all of this. But for the time being, there are a bunch of files here. You can learn about them also in the lecture to figure out exactly what a layout is and exactly what all this stuff is. But great, as you can see, it's a mix of Java code. You've got some XML in here. You've got some test code. You've got some unit tests. It gives you some nice stuff right out of the box. So I think the first thing I'm going to do is I'm going to commit this stuff to Git. Now, because I created it inside, got a bunch of unversioned files. It might be easiest if I just do this from the command line. So here, if I do a git status, I've got an airline Android directory, and so I will just add that to Git. That's nice. And now if I do a git status, I've got a whole bunch of new files. This is all cool, and I'm going to commit these. So I'm going to say added airline Android application. Oh, how alliterative of me. Okay, and push that up to GitHub. Okay, now if I go and refresh, no local changes, this is good. Okay, so now I've got my application and I have built it. So now I can do things like I can run my unit tests. Out of the box is a kind of a dumb unit test, just shows an example of what what can be done. Oops. Oh yeah, and out of the box it uses the old JUnit APIs. And in a moment here, we can fix stuff like that. It took a while to build, but I guess it had to do all sorts of things in order to do that. One of the things you'll find is that an Android application is even more complex than the applications you've been dealing with, so things just take a little bit longer. We get some pretty cool results. So, okay, I've got some source code, and I can do things like I can run unit tests. They also have these things called instrumented tests that are like integration tests. They actually will go and launch parts of your application and let you interact with them. There's some information about this in the lecture, so I'm not going to go into it right now. But instead, what I want to do is we want to run this application. So we want to select App here, and when we do that, it says No Devices, which means that I haven't installed any emulators yet. I haven't installed any Android devices to run this application on. So and actually, some of the ways that you can do it is that you can plug in a device if you want. Apparently, you can pair them using Wi-Fi now. And something about the Wear OS. Well, that's neat. We're not going to do anything that fancy, but instead we're going to select Device Manager, and this opens up a tab. I'm going to move things around a little bit so we have some more screen real estate. And then this section over here allows you to create these devices. I'm going to close the chat. I'll put it over here. And so you can first of all select the type of hardware that you want. I'm going to test things on the Pixel 2, 5-inch Pixel 2. I recommend that you do the same. And so you have all sorts of choices. So again, here are emulators for all sorts of different phones. So all the line of Pixels, You've got Nexus phones, just other various kinds that are all all can be supported here. You can also have emulators for Android TV, for Wear OS, tablets, various Nexus lines there, Pixel C. It's actually pretty cool. And boy, they make it really easy. So I like it a lot. Oh, I guess if you want to fetch new ones, you can refresh here, although probably these are probably all the most recent ones. So I'm going to select Pixel 2. I'm going to say next. Now so basically you've selected your device emulator. Now you need to select the operating system, the system image that you put on it. I recommend again version Q, because that'll match the runtime that we're using in our application. Oh, you probably need to click download and accept a whole bunch of things again, because my environment isn't as clean as yours is. You'll have to click download and then again install a whole bunch of other things. Once you've done that, oh, and that's also where you might need to, on Intel machines a long time ago, you need to install the Haxem stuff. I don't know if that's still the case or not. And you click next. And now you're creating your device, give it a name. I just choose the default name. It just reminds you which device and which runtime they're using. You can select which startup orientation. So you might as well just go with portrait, et cetera, et cetera. And there are probably a whole bunch of advanced settings that aren't interested. Oh yeah, but just to point out all the stuff that the device has, you can specify, what cameras are there. You can configure things about the network. So for instance, if you want to test your application with a flaky network, you can, you've got all these different, right. So let's say you're on a GSM network that's slower, you can, or an LTE network, you can select all of that for your device. And various other things. You can specify like how much storage it has. Apparently you can't set things like RAM and VM heap, so maybe that's all built in. But anyway, all this are really cool stuff. And the reason I point this out is not because you're going to be changing it, please don't. It just really goes to show that they want to enable developers to be successful with this platform, and so they let you do all sorts of advanced things with the device. Okay, I'm going to finish this. So I'm going to create one of these, and so what that does is then creates this little software emulator that for that device running that image, running that operating system. And now up here, I'm going to hide these controls because they get in my way. Now, when you select the app here to run on this device, the only device that we have, and you click run, this will start the emulator. So it's starting the emulator right now, and emulator is running in the background, and what it's doing is now it's building the application. Let's go back to the build so we can see what's going on here. Now it's building the application and deploying it to the emulator. So the emulator is running there in the background. This is installing the app onto the phone. And there it is. We've got our Pixel 2. This is way too small for me to see, so I am going to, let's see, what do we need to do here? View mode, window, cool. Now we've got it in a separate window. It's still booting up right now. It's booting up for the first time, so it has to initialize stuff. And by the way, this is running the same software that the actual phone would run. And so it's basically like, hey, I just bought a new phone, and now I've got to, initialize and everything. Cool. Okay, so there it is. So there's the application, or rather, there's the phone. And I think pretty soon here, I would expect the application to start up. There it is. Okay, here is our airline activity, and it's saying hello world. I'll try to make it a little bit bigger so we can see that. Yep, and there is our application. Now, this is a thing that basically, is just like the phone, right? So we can't really interact with the application very much, right now, but you've got the 3 buttons just like you do on any Android device. And so you have, the plus that lets you, it goes back to this screen mode. And you can do things like, simulate, flicks and interaction just by clicking and dragging the mouse. So I can just kill the app like that. And it comes with stuff pre-installed. And so I can run Chrome here on the phone, and it actually gives me the Chrome application to to do its thing. And this is the same Chrome that runs on any Android device. All right. So now we can. Oops. There we go. It can be a little slow sometimes. It can be very slow sometimes. Woofed. Let's try this one more time. Nice. Right, and here is the, obviously my website is not optimized for small devices, but it works. So anyway, that is the application. So we're going to leave the emulator running and make some other changes. Before I do, I want to pause for questions. I know some of you are playing along at home. If you're playing along at home, have you encountered any challenges, or do you see anything drastically different than I have that other students should know about? Eric says, so far so good. That's cool. Okay. Nice. Because again, your mileage may vary. Let's see here. Oh, okay. Yeah, Mina says that she's still getting set up with the new project. Choose a template. Which template do you pick? The basic. It's there on the page. Wait a minute. Let me look. What's it called? Basic project. My first app. Oh, sorry. Wait. Empty activity. There we go. Empty activity is the one you should pick. You are welcome. Anyway, again, this has really great documentation. Let me just take a couple minutes and walk through some of the code. I will resist the urge to dive deep tonight because this is all still very new and people are still getting set up. Plus, we want to have plenty of time for mod programming. But let's just take a look at a couple of the things that are here. Now, let's look at the Java code first. There's a class called main activity. And an activity is essentially, you can think of it as a screen. For now, for the first day working with Android, think of it as a screen in your application that you go between. It's an activity. It's something that the user can interact with. And actually, it reminds me a lot of a servlet in that it's a Java class that is instantiated behind the scenes, and then the Android runtime interacts with this object based on what the user does or based on what the life cycle of the activity is. And so you'll learn about this in the lecture, but activities have a bunch of methods that correspond to their life cycle. An activity goes through a life cycle. Basically, it's like, oh, I'm being displayed. Okay, time to create me. And it's like, oh, I'm being, put off to the side. Okay, time to tear me down. Or hey, I'm the application is being killed. Deallocate, deallocate me. Okay, great. I'll, close my database connection and I'll save my state or do whatever I need to do based on that. Here we are doing some very basic stuff. We're basically saying, hey, when this activity is created, call the inherited onCreate method from appcompat activity, and then say, hey, great, and I'm going to display r.layout.activity main, which is basically a reference off to the UI elements that are displayed in this activity. And you can navigate to them in a couple of ways. You can click this icon over in the gutter here next to the class name, which will bring you to an XML file. It gives you this little pop-up here. And you can either have the Android manifest, which describes the application itself. That's probably not too interesting for you. What's more interesting is this activity underbar main.xml. And this is an XML file that describes the layout. Now, when you go and you edit this, it puts you into the visual editor. Let's see here. Where is the, it looks a little different than the last time I saw it. Where is the raw XML? Oh, here we go, code. So in Android, and we dive into this in the lecture, in Android, you have an XML file that describes the UI. Now, this UI is super simple, right? So let's go back to the emulator. Oh, wait, there's the emulator. You can open it up, and it's the airline activity right here. I mean, we should just call that airline, but whatever. All it has is hello world. And that's because here, this activity is described by the UI for this activity is described by this XML, and all it has is a text view widget that contains the string hello world. Right, and that's all it needs to do. Because they're just getting started here. And we can talk about all of the constraints and all that stuff, again, at a later time. Now, this is the XML view, and it's nice that it's an XML because XML is really compatible with version control, right? You can check this file in, and as you change it, you can roll back and everything like that. It's text-based. It works really nicely that way. However, writing raw XML is not necessarily the best thing in the world. And that's why Android Studio lets you also go in design view. And so here you have a visual editor where you can do things like change the name of the you do things like change the name of the text. So we can say hello Java. And so then, oops, now it is, if you can, let me zoom in here. Now it says hello Java. So I changed that. I changed that here in the visual editor, and let me go back to do that again here. So over here on the right, you have all the attributes of the elements that you're dealing with. I'm going to click on the element for the hello Java text view. And I'm going to scroll down here. It has all sorts of stuff like, you can rotate it and all. I don't know, you can probably mess with it like oh, that's wacky. So X and Y. That's new. I remember having that before. Okay, now you can have it like on this funny angle and stuff. And then, there are tons and tons and tons of different attributes on that text object. But finally, what I wanted to get down to, oops, where'd it go? Can I search for it? Oh, can I search? No. Somewhere here I should have the text. Comment attributes. No, wait, I'm clicking on the right thing. Yep, text view. There it is. Hello Java. It's probably, yeah, I'll fix that in a moment. Okay, so and this is where you can change the text again and say hello Java class. And there it shows it off here. Now, when I make that change, when I do that rotation and stuff, those changes are reflected in the code. So now it has more properties that are set here in the code. Well, in the XML. And so we've changed the hello Java. Okay, we've got the change bars over here, and we've also done some rotation. Now, when I say code, it's XML. It's an XML representation of something that's ultimately a Java object. So, what Android does is when the Android application is built, it reads this XML file and creates Java objects, or creates code that will create Java objects that represent all of your UI widgets. And this is actually a really nice thing because ultimately you have a Java object, and we'll see next time how you can interact with those Java objects in your activity code. And this is how you respond to interaction with this. I mean, so we'll see that, hey, you can have a button there in your UI, and then you can have code in your activity that says when the button is clicked, go do this thing, right? You know, pop up a dialog or whatever. So anyway, so we've changed that here. We've made a change in our application, and now we want to deploy those to the emulator because, you know, right now the emulator is still running the same thing that was before. So if we restart our application, our airline activity, it still says hello world because we changed the code, but we didn't redeploy the application. So now we'll do that. We'll get the build up here, and we will click this button. Well, we have run app, and then we also have like apply changes and restart activity. So let's just try apply changes and restart activity and see if that's good enough. I think in this case it will be. Okay, so then it's built it, and now it is deploying it, and there you go. It reloaded it, and now, wow, you have this really hard to read hello Java class, but it changed. So this is the build cycle of your application. It's the same way that you'll see in Project 5. Every time you change your servlet, you need to restart your Jetty to get the changes. Same thing here. You make a change to your application, and then you need to restart it to, well, make a change to your source code. You need to rebuild and redeploy the application to the Android emulator in order to see the change. Change some attributes. Oops. Label. Any questions on what we've seen so far? Nope. Okay, then. Let's take a quick break. Let's take 10 minutes and quick pause, refresh your glass of water or whatever it is that you're drinking. And we'll be back at 6:40. We'll spend a little bit more time diving into this application, some of the source code things, before we look at the assignment. So 10-minute break. Okay, everybody, welcome back from the break. So at the beginning of class, we created our first Android project by downloading Android Studio, by downloading all of the pieces parts required to run a Android API version 29 application on an emulated Google Pixel device. And we did stuff in Android Studio and a lot of stuff out of Steam familiar to people, things like using the Git integration and browsing files, because it's built on top of IntelliJ. And so it's what we've been using all term. Let's see here. There's one other thing in the configuration that I want to walk us through. So ultimately what we're going to do in this project, and we'll get to the project next, is you'll be using classes from your airline application inside your Android project. And those classes require my classes. And so then in order to have your project depend on my classes, your code you can just copy in from your other projects. But we'll need to establish a dependency on my code so that the code that I write, things like, you know, abstract airline and text dumper if you use that, or not text but airline dumper if you use that, are in this other jar file. So what you need to do is you need to make a couple little changes, or one little change to the build.gradle file inside the app directory. So let's go find that over here, and I believe it's under Gradle scripts. And I believe it is, this is the Android view. Where is the project source files? Source, I know they're just source files, they don't have build files apparently. Lame. Project. Here we go. Here's app and app build.gradle. So Gradle has this DSL, the L's language. What does the DNS stand for? I'm totally blanking on that. Sorry. But what does DSL language? Domain specific language. There we go. Yeah. Domain specific language. Hoofed. For describing the build and configuring things. And so then, this is where you can say, oh, here's what, JDK I compile with and things like that. What we want to, actually, this is kind of important to look through, I guess, because it says, hey, the language that we're going to be using is Java 1.8, and maybe that's something that you can change. I know that some of you have been using newer language features, and so then if you're like, hey, I want to use, something from, I don't know, like the integer constants, or maybe the triple quote multi-line string or something like that, let me know if you want to change these. I can never remember what language versions Android supports now, so it may be that you can't use the latest and greatest with Android, and that's because the Android has its own Java compiler, and so then as the official Java people are releasing new versions of the language, the Android folks need to catch up because they compile the source code down to bytecode for DEX. It used to be called the Dalvik VM a million years ago. But they have their own runtime, they have their own virtual machine, so they have their own compiler to generate code for that. We care about this dependencies section here at the end. This is the thing that specifies all of the third-party libraries that the application depends on. And so we want to add this line and make an implementation dependency on my projects right there. And it looks like it doesn't like the quotes that are copied in from the PDF. Big surprise there, so you got to fix that. There we go. Okay. And now, oh, good. It's telling me Gradle files have changed since last project sync. Sync project may be necessary for the ID to work properly. Yes, please sync now. And so now it's just, update. Basically, what it's doing is it's reading the Gradle files and is updating the IntelliJ configuration appropriately. And now this will let us do the following. So, how best to do this? Well, now in my main activity, I ought to be able to do something like the following: private void create airline. And so like now what I want to do is I want to let's see here. I want to put my airline code in here. You can just copy it. I suppose I can copy it from the command line just as easily as you can. So copy from my airline. It's from my airline web, which probably has my latest source main Java edu pdx blah 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 airline.java. Copy this into airline Android source app, the app directory, source main Java, the Whitlock directory. So now go back here to Android Studio. Now it's got airline. If I open it up, oh, interesting. Oh, that's right. Airline takes flight, so I'm going to need the flight class in there also. What was complained with the package? What was it saying? Oh, interesting. It has like a, I used a little j instead of a big J. Okay. Let's see here now. There, that's happier now. So I also need to copy flight in. And I will also need to fix the J. But it knows about abstract flights. Yes, it has the right dependency and everything. So that's good. So that means that I can now use airline and flight in my Android application. Oh, or is this the urge to write more code now? Because you've already seen a lot. Okay, but now we should be able to deploy the application again, make sure everything builds. Looks like it does, and we've still got, let's go find our emulator here. Right, there it is. Still ugly looking. That's fine. Okay, nice. So I'm going to commit this code. I'm going to add those two on version files. Go up there. Yay. Okay. So add the airline and flight class. Include the dependency on the projects. Oops. Projects jar that contains the abstract classes. Oh, you know what I don't have in my Android Studio yet is the plugin thing that pops up all the keyboard shortcuts. But they're the same keyboard shortcuts that I use in IntelliJ. Not doing anything terribly special here. Okay. So there's a couple more things that you need to do to get the project up and running. And now we're ready to code. Any questions on what you've seen so far about working with Android Studio, about working with the application and deploying it to the emulator? Nope. Okay, I'm going to stop the emulator then. Oops. Let me... Where is the, oh, where'd the emulator go? That's weird. I can stop it up there, I guess. Oh, there it is. Okay, and yeah, and actually some of the stuff you can do with the emulator is like you can turn it off. So you can power down the emulator right there. You can also just close the window. Maybe not. Device manager. Okay, yeah, it looks like it's. Interesting. Yeah. Oh, actually, one thing. We'll see this again next time because it'll be more relevant. We'll talk about how to work with files and stuff. Is that there's this, so that you can get you can look at the emulator like that, and there's also the there's also a file explorer. I will see next time that there's a file system on the emulator, and you're going to be writing files to it as part of your application, and so this is where you can find stuff. And speaking of which, okay, Now we've gone through like, here's how to get started with Android. Let's actually talk about the assignments. Okay, so here we are at the culmination of the class, the final project, a small device application for an airline. And so we've taken this application from some very simple Java classes in Project 1 all the way through working with files and formatting dates, working with XML, and then turning it into a client-server program with a web application and a REST API. And now we evolve it one more time to be a small device application. And so this gives you an opportunity to learn about Android and to work in this development environment and work with these programming APIs that are just a step beyond what you've done so far in the course. And so what I'd like you to do in this project is develop an Android application that has all the functionality of the previous assignment. So mainly creating an airline, entering flights, pretty printing, searching, all of that kind of stuff. The capabilities of the other projects. Note, however, that this is not going to be a client server. Everything's going to be contained in the just on the in the Android app. You're not going to be communicating with a server. You could, but that's a step beyond. I want you to focus on developing the Android application here. So you won't need your servlet from Project 5. Now, the first, I'm referring to the first activity, the initial screen in the application as the entry point. And there's I have some requirements on there, although the vast majority of it is completely up to you in terms of how it is implemented and how it looks. So there should be a help menu that has a README item. And this is how you get information about the application, right? This is the equivalent to the dash README option. Instead, you have a menu where you say, hey, show me the README. If something goes wrong, so for instance, maybe the user provides bad input, or hey, there's some processing error, there's some logical error or whatever, please pop up a dialog box that describes the error. And it should be concise enough so that it looks decent, but also detailed enough so that people know what's going on. So it shouldn't be just like an error occurred, and it shouldn't be like 10 lines of text describing what went wrong. Errors should be handled nicely. And note that in general, pop-up dialogue should only be used for conveying small pieces of information. I've had students in the past where like every interaction would pop up this big dialogue or whatever. I don't think that's very usable. It was kind of hard to work with. So for instance, don't use a pop-up to display the contents of an airline. So if you're doing a search or something, don't display all the flights in a pop-up. Instead, use a different UI widget for displaying the contents of an airline. So, where I was pretty prescriptive in terms of what the other projects should do, this project is meant to give you an opportunity to exercise your creativity. So I'm not going to draw a picture of what I expect the UI to look like. Part of what this project is all about is designing a user interface which is intuitive enough so that someone like myself who has, knows what the airline application does and everything like that can pretty easily figure it out. And go through and exercise those capabilities. So the ability to, again, create flights in an airline and search for them and pretty print them and all of that kind of stuff. But please, use your creativity, your imagination when designing your user interface. So before I go on, those are that's the general shape of the project. Any questions about what the project should or should not do?
So as far as like the entering in any data goes, it's totally kind of like that's totally open to interpretation of how we want to structure that and let the user kind of do all that.
Yes. You've got lots of options with Android. As you learn about more of the widgets that are available, I encourage you to use the ones that make sense. I'll say that, students have projects, the past have ranged from simply, entering in text, which is one way of doing it. But they've also had drop downs. They've also used calendar widgets, clock widgets, things like that. Explore, see what's out there, see what makes sense for you.
Awesome, thanks.
Yeah. Okay. This, so, you know, in the other projects, I was pretty strict about what could and couldn't be submitted. But this is, you know, I can't be that strict here. There's going to be XML files that you submit. Your Gradle files are going to be modified. All sorts of stuff. So I have a different submit tool, and actually, I think these instructions are out of date. I apologize for that. I believe I've augmented the submit script to support the Android project. So I think if you say project 6, actually, why don't I just go check that out? GitHub, Portland State Java, getting started. Oh, actually, my winter 2022 ought to, let's say that. So yeah, I believe that I updated the submit script so that, yep, if project 6, then this. So I think you should just be able to say project 6. I'll update the PDF shortly to refer to that. So, but there are a couple of important notes here. You do, even though you submit the code from the CS department's Linux machines, you cannot run this code on the CS department's Linux machines, right? There isn't an Android development environment, or if there was, it would be painfully slow over, you know, a remote X client or whatever. So get it working on your local machine. Push it, you know, put into Git, commit to Git, push it up to GitHub, pull it down on the CS department's machines, and use the submit program, the submit script to submit it from there. Very rarely has there been any problems with that. Project 6, just heads up, I grade this one, so the grader will be focusing on your final exams. I'll be grading this one, and I do that for a couple of reasons. First of all, this one's fun to grade. I mean, it's always so cool to see what the students always come up with, and so that's really neat. But also on this one, we kind of need to have some rapid back and forth if something doesn't work, or you know, if there's a question that I have. So, you know, I want to be in the middle of that so I can provide, you know, rapid turnaround, especially when it comes to like regrading and things like that. So, oh yeah, so note that the Android projects I will grade on my personal machine. So I will, I'll change this shortly. Oh, a couple of things here in the footnotes. You know, there's a POA for this project. And of course, as always, it's due 36 hours before the project, so Sunday night at 5:30. And I recommend that you do a little bit of UI mockup before. Parentheses are messed up. Using a tool, I like this tool called Balsamic, which allows you to sketch things out in a way that it makes it clear that you're just sketching it out. And it's not trying to be like a true to life mockup. And feel free to attach, you know, any files to your POA. Oh, and note that I guess one thing about dates and times, if you're going to put it in as text, that's fine, but please make sure that it matches the format of the previous project. Not like, you know, oh, you know, European format or something like that. That'll confuse me and you'll lose points. So please use the same format. So this next session here is a reiteration of kind of the things that we did in class. So again, if you weren't following along, or if you need to start over or whatever, start with this URL and use the Pixel 2 API 29 emulator. So like I did, you'll need to add this dependency. I need to figure out whether or not you can use JUnit 5 and Hamcrest APIs with Android. And I'll look into that between now and next week, and I'll let you know what I find. You should also feel free to do the same if that's something that you want to do to start with. Oh, just a couple of notes about some more things about the application. So in the REST API, you know, you weren't required to write out the contents of the airlines to storage, meaning that when you stop your Jetty server, all the airline data goes away. For the REST API, that was fine. For the Android application, though, I want the data in the app to survive the closing of the app. And so then please use the Android internal storage API, and there's a link off to that there, to persist your airline data. And this API basically gives you a Java file API for some locations there on the device, and so you can use that to save your airline data. You can use either the text file format or the XML file format. Doesn't really matter to me. Now, just some notes about how I will grade it. So when you run the submit script, that sends me a zip file. And so what I'll do is I'll extract that zip file to the file system. Please make sure to submit the following. So the app directory with all the source code. Do a Gradle W clean and a Gradle W build on your personal machine to make sure everything builds before you submit it. When you run with Gradle, it's a little bit more strict about smelly code. And so then I recommend, so if you run into some lint problems or whatever, first try to fix it because it's telling you those things for a reason. It's good advice, but you don't have to take it, because ultimately what I'm going to do is when I grade it, I'm going to run this command line, which takes all the linting and things like that. I'm not going to, because if it fails the linter, it won't build. I'm not going to give someone a 0 because they had some smelly code. Not on this project anyway. So make sure to submit your app directory, your build.gradle, your gradle.properties, your Gradle W script, and the settings.gradle. Those are all the things that must be submitted. I'm pretty sure that the submit program does take care of all of that stuff. Oh yeah, and so I will run. So when I grade your project, what I do is I run Gradle W build. Actually, I run this big stuff up here. This doesn't run any of your tests, and so this is something that's important to note. All during this course, we've been doing test-driven development, and I've measured your, I've assessed you on your test coverage. We're done with that. This last project is meant to be exploring the Android APIs. It must be kind of fun and stuff, maybe not as rigorous as the other projects, because trust me, there'll be plenty for you to learn. So I'm not going to run any of your automated tests. I'm not going to measure your test coverage with this. I'm also not going to generate API documentation. You already learned that stuff. You've been assessed on it plenty. Really, what I care about here is, what I really care about here is that you get to play with the Android APIs, that you get to build the application and focus on that. You already know how to do JavaDoc, and even though automated tests are different for Android, we're not going to take the time to write automated tests and really study how to do test-driven development with Android, even though it is possible. Oh, Eric, thank you for doing that Googling. If you found a really good reference, I'd appreciate if you could share it here in the chat, and I will amplify it out to the rest of the class so that they too can use Hamcrest and G-Unit 5 if you like. They'd like. Also, just for reference, here's how I'm going to launch the Android emulator, just in case you're doing the same thing at home. And then I'm going to run Gradle W install debug to deploy the application onto the emulator. After I test it, so I'm going to sit there and manually poke around it. So there aren't automated tests for this. It's not like an automated test script. Instead, I sit there and I have a series of test scenarios that I put in data right and wrong, and I try to break your app. And based on that, I will then record what I see for each one of those scenarios and assign you a grade accordingly. After I do that, I'm going to run Gradle W uninstall all to uninstall your application from the emulator. And that is project 6. That is due in March 16th, which is, I believe, 3 weeks from tonight. So your project 5 is due next week. So I expect everybody to be focusing primarily on project 5 for the next week. Although please make sure that you can at least do what we did tonight, which is install Android Studio, create a new application, get your emulator installed, run the application on it, and then add a dependency to my code so you can import in, so you can bring in your airline and flight classes and anything else. Any questions on that? Nope. Okay. Nice. Well, that's all the live content for tonight. The remainder of class will be a code kata for mob programming. So here, but let's take a break first. Let's take another 10-minute break. Come back at 7:20. Again, this is all of like the new live content. So I encourage you all to do some more mob programming, but remember, only one mob programming activity is required for the course. And so if there's other stuff that you want to do tonight, you don't have to come back. But let's take a break. Who's ever here after the break will do some mob programming. I think you'll enjoy this cause. It's a pretty cool one. Okay, hey everybody, welcome back. Looks like a handful of you hung around. Thanks. We got 8 people. That's a great number for a mob. So let's dive into it. So last week we began to explore mob programming or ensemble programming. As I'm trying to refer to it more, I like the name. It's reminds me more of an orchestra playing together. And we saw that it was a little different from pair programming. We've got more people, more eyes on the screen, more ways of collaborating, more ideas to throw around. So let's do that again with a kata, which is called the RPN kata. So I will post this in the chat for everybody to peruse. But the whole idea here is that you have a RPN calculator. RPN is reverse Polish notation. So the whole idea is that it's like a stack-based calculator where you have a value, another value, and then you have an operator. And the operator will then consume the two previous for a binary operator, it will consume the 2 previous values and then pop that new value. We'll pop the 2 off the stack and then push the new one on the stack. And this allows you to have to express kind of complex arithmetic expressions in a way which can be easily interpreted by a computer. So for instance, if you get an input like 20 space 5 space slash, this represents the operation 20 divided by 5, and so the result of this will be 4. Similarly, something more complex like 4, 2 plus 3 minus is first you do 4 plus 2, and you pop that back on the stack, and then you say 3 minus, and so you end up with 4 plus 2, which is 6, minus 3 equals 3. So this is another kata that grows over time. So at first, you just support the 4 basic arithmetic operators, plus, minus, times, divide. But there are more operators that you could add, like square root. So this is a unary operator. So it just takes on whatever on the stack before it and performs a square root. And then there's also, for bonus points, you can have the max operation. So this returns the max of all of the preceding elements on the stack. So here, we have all these numbers, 5, 4, 3, 2, 9, 1 max. This refers that this is really then the max of all those other operations, and then that equals 9 because that's the largest number there. Similarly, you can have max in the middle of the stack, and so then this is an operation there, and then you have this max to all this, and then you. Oh, that's interesting. Oh yeah. So okay. So the way you interpret this is that you first have the max of 4 and 5, and it says times the max of 1 and 2, which is an interesting way to interpret that, equals 10. I don't know if you can actually get that to work. That'll be interesting. Anyway, this is a cool little one, but it usually takes a little while to work on it. So again, I'm after I do a call for questions, we'll go into a breakout room, and then someone can create a repository, or rather create a new project using the create kata script, and I encourage you all to mob on this. Any questions before we get started? Not, I'm going to create one breakout room and let you all choose to participate. And I'll poke my head in after a while, maybe even participate with you if you want. But I'm really curious to see how this goes. We should have a nice group here in the breakout room. Here we go. Okay. Awesome. So you finished. Tell me all about it. Show me the solution, and someone walk me through it. Jacob's on mute, so who wants to?
I could do it if you want.
Yeah, that'd be awesome.
Here, let me let's see here. Let me find a good way to share this. All right, let's see. I'm still connected to the code with me, so hopefully it doesn't blow up.
Oh, sorry. Just a second. Do you want me to put it on the room audio? Okay. Let me, let's see here. Turn that off. And then. Yes, I would. Speaker. Cool. Eric, can you say something?
Yes, can you hear me?
That sounds awesome. Thank you.
And do I have the booming voice of God in the room?
Pretty much.
Excellent. Finally.
There you go. Yes, your Dominion, both of us. I was going to say.
So yeah, I mean, we basically went the route of doing a stack here, iterating through pretty much splitting up the whatever argument string of that reverse Polish notation, splitting it up into tokens, and then going through from left to right on that. And if it is a number, pushing it onto the stack. If it is an operation, since these are binary operations here for these first ones, we'll pop the two elements and then do the operation here and then push that onto the stack. Then for the square root, I mean, it's just the 1, right? Since it's a unary operator. And then max was where things got a little bit hairy because didn't quite make sense. And so we spent a long time talking about it.
Yeah, and what'd you end up with? So I got to admit, yeah, when I saw that too, it's like, that doesn't make sense. So were you able to implement it the way that it was there in the kata?
No, we decided they were wrong.
Yeah.
Yeah, Jacob ended up writing for the first one that they gave, where it takes a max of the whole stack.
Did you try it with the two maxes to see just how it behaves?
We have a test case for that, and the functionality that like should exist is you end up with only one value left on the stack and the multiplication operator. So you end up with not enough, like following the logic of how everything else seems to work and how the first max example works. We spent a lot of time discussing how to
Yeah,
do
because
that.
it was like going with the first one, if you do a max of, a whole bunch of stuff, like if you do that kind of functionality, then for the second case, if you do, following this, it would go 4, 5 max, then it's got 5 on the stack, then 1, 2 max would get the max of 1, 2, and 5.
Right. Yeah.
And then
Yeah,
you would,
and so yeah, if it's greedy like that. Otherwise, yeah, I can imagine you'd have to like have a completely like different code path and logic for like the maxes of what they were saying. Yeah.
Mhm.
All right, cool. Well, nice. I mean, you made pretty quick work of this, all things considered. Probably spent a little over an hour doing it. What was the experience like? So, what was this particular mob like? What were some things that were effective? What were some things that maybe weren't so effective?
like I appreciated we definitely did like a ton of discussion even before we really started implementing stuff. So it's kind of interesting. Just instead of a route of like writing a bunch and watching it break a bunch of times, it was more of like make sure that we all kind of understand the route that we're going to take.
Hmm.
And I thought that was interesting.
So, other folks, what were your observations about this this mobbing, and maybe how it's differed from last week's mobbing, or maybe some of the pair programming that you've done earlier in the term?
I feel like I kind of feel like this the same way. I didn't do the mob programming last week, but like with pair programming, I feel like working with other people, it's always interesting the way other people choose to do things. And since we discussed it so much, it was sort of interesting how we arrived at the implementation we came up with. And once we agreed on what we were going to do, it was pretty quick. I feel like just in general, I find the code ends up a lot cleaner, like a lot faster when you have more eyes at once, and like small errors get caught a lot faster.
Nice, good observation. Excellent. Well, good deal. Well, congratulations on getting this one done. This one is not straightforward, but you know what? I mean, yeah, that method's a little bit long. I mean, we could like be a little bit more object oriented about it, but you got a solution and you got tests that demonstrate it, right? So that's pretty awesome. Great. Okay. Well, hey, thanks for taking the extra time. I hope it was a good exercise for everybody. We've got one more next week. Next week is we're doing Minesweeper. What are we doing next week? We are Minesweeper next week. That'll be fun. I might even join in the party then. Cool. Excellent. Okay. Awesome. Well, and that's everything for class. Anything else you want to discuss before we break? No. Okay. Thanks again. Thanks to anybody who's watching at home. Have a great week. I will see you next week. Bye now.
Bye.
Thank you.